All right. Our whole goal is to find out, the goal at the very end is to find all the actual zeros of this polynomial. How many zeros should I have when I'm done? For those of the cameras on, you can maybe just show me fingers.
5.
Good. 5. Should have a total of 5. And that 5 comes from this. In the standard form, it's the biggest exponent, and I know that I need to have a total of 5 by the time I am done. Those are going to come from all of your possible zeros. And that's what we're going to list out here. However, to get to those numbers, we need to first find out the factors of our constant, which is negative 14, and the factors of our leading coefficient, which is 1. So the factors of my constant, two numbers that multiply to give me 14. 1 with 14, and then 2 with 7. And that's it. So those are all my factors of 14. So now I need the factors of my leading coefficient. My leading coefficient was 1, so my only factors are 1. Now, possible zeros are all of these numbers divided by all of these numbers. So I'm going to kind of show you with highlighting what I'm doing. 1 divided by 1 is 1. 2 divided by 1 is 2. 7 divided by 1 is 7. And 14 divided by 1 is 14. So how many possible zeros do I have?
8.
8. Good. I have 1, 2, 7, and 4. All of those are positive and negative. So I have 8 possibilities. So instead of guessing which ones of those are actually going to work, we're going to use Desmos. I'm going to show you how. You take this here and you type it into Desmos calculator to see the graph. And this is the graph we see. Our whole goal, or what we're looking at with this picture is, where is it touching my x-axis? And I notice that it's touching it at 2 spots. Here, when x is 2, and here, when x is a negative 1. So I'm going to try negative 1 and a positive 2, and those both should work. So negative 1 and positive 2. So here's the thing that I kind of was relating to on Tuesday, I believe. Notice that at 2, if this was my x-axis, it went through at 2. But at negative 1, it hit it and bounced. This one means I have a multiplicity of 1, meaning 2 is only going to occur once. This one means I have a multiplicity of 2, meaning I actually know 3. I actually know 3 solutions right now, or 3 roots. I know 2, And I know -1 is going to show up twice. So I have all of these here to use, which means my last two that I don't know of, because I need a total of 5, my last two are going to be imaginary ones. So they're going to have an I in it. One last piece I want to show you is there's a third one. If it's a multiplicity of 3, it's going to hit, and when it hits, it's going to do a little curve. So through, bounce, curve. All right. When I have 3 options, and I know I have 3, -1, -1, and 2, you may pick whichever one you want to start with. All 3 will work at any point when we're doing this, in any order. So you can pick whichever one. So I'm just going to go in order, and I'm going to start with -1. Now I find my coefficients. 1, -4, 4, 10, -13, -14. We multiply, we add. Multiply, add. Multiply, add. Multiply, add, and multiply. I got 0, which means that was a good pick. It's working. So I've used this one already. Now I'm gonna do -1 again because I had it as an option of twice to use. But this time I'm gonna use -1. With the numbers that I just found, these down here. So 1, -5, 9, 1, -14. Multiply, add, multiply, add, multiply, add, and multiply. Okay, so now my last one to use is going to be the 2 with these new numbers. Multiply, add, multiply, add, multiply.
Yo, hello.
Since that worked, I am now left with this. if I try to do the super x for this last piece here, it's not going to work because there is no number that goes into 7, two numbers that multiply to 7 and add to a -4. So to find my last piece, I'm going to kind of shrink this all down. I'm going to do the quadratic formula. One quick question that came up right now was confused what we had to do while we factored -1 twice. When we looked at the graph, -1 bounced. It was like this. It kind of just bounced, which means it gives me the option. I know I have a multiplicity of 2 for -1, so I'm allowed to use it twice. If it cuts through, it's only once, which means you can only use it once. All right, so I have this, x squared minus 4x plus 7, and I'm just gonna do the quadratic formula. X equals -b plus or minus the square root, b squared minus 4ac, all over 2a. All right, what is my a in this problem? What's my a value?
1,
1. What's my b?
-4,
And my c.
7.
7.
Good. I plug in everything I know. And I just solve. Double negative makes a positive. 16, 4 squared is 16. 4 times 1 times 7 is a -28. Now we need to simplify the 12. 12 is 4 and 3, which is 2 and 2. Pairs go on the outside. Singles go back on the inside. Two I radical 3 over 2. The I comes from the negative inside the square root. And what's my very last step?
Simplify.
Simplify. I'm looking at the 4, the 2, and the 2. 2 goes into all of those. I'm going to simplify to give me an answer of x equals 2 plus or minus I radical 3. How many answers should I have had? Five, right? Should have had 5. So I have, if the question said was one of these, what are all the factors, what are the zeros? You would just write them out. 2 plus I radical 3, 2 minus I radical 3, -1, multiplicity of 2, and 2. All right. The constant, 12. My factors are plus or minus 1, 2, 3, 4, 6, and 12. Leading coefficient is 10. My factors are 1, 2, 5, 10. My possible ones. This is going to be a long list. I am starting with the 1 first, dividing all the top ones by 1. 1 divided by 1 is 1. 2 by 1 is 2. 3 by 1 is 3. 4 by 1 is 4. 6 by 1 is 6. And 12 by 1 is 12. Next, dividing all the top ones by 2 now. 1 divided by 2 is 1/2. 2 by 2 is 1, so I don't need to rewrite it. 3 by 2. 4 by 2 is 2, so I don't need to rewrite that one. 6 divided by 2 is 3, and 12 divided by 2 is 6. Those are all written. I can move on to the next one. Now dividing all the top ones by 5. Plus or minus 1 over 5, 2 over 5, 3 over 5, 4 over 5, 6 over 5, and 12 over 5. And my last one, dividing it all by 10. 1 over 10. 2 over 10 is 1 over 5. I already have it. 3 over 10. 4 over 10 is 2 over 5, so I already have that one. 6 over 10 is 3 over 5. I already have that one. And 12 over 10 is 6 over 5. I already have that one. How many possible roots do I have here?
Six,
16.
32.
Okay, I have
32,
16
yeah.
numbers.
Yeah, 32.
Positive or negative would make it 32. Thirty-two possibilities out of how many zeros in this answer? Four. I'm only gonna have a total of 4. Now that doesn't even include imaginary numbers here. So once again, use Desmos to find the one that's going to work for you. Let's look at Desmos. Get rid of that one. Here's our problem. So if I start clicking on all of them, that one is too hard to even determine what fraction it is, because it's actually going to be a complex root, meaning we're still going to have to use blinking out quadratic formula to find that one. Same thing with this one. We'll use quadratic formula to find that one. So it's going to come up with both of those as my answer. However, I can find out this one, which is a -1/2, and I can do this one, which is a +3/5. So if I go back, I am going to use -1/2 and a +3/5. I'm just going to go with the half first. My numbers are 10, -11, -42, 7, and 12. Multiply -1/2 times 10 is a -5. Then you add. Multiply. Adding gives me 34. Multiply. Add. And multiply. Do it again for 3/5. I'm going to use these new numbers. I'll answer that question right now. Okay, so 10 times 3/5. I just do 10 times the top, then divided by the bottom. 10 times 3 is 30, divided by 5 is 6. -10 times 3 is a -30, divided by 5 is a -6. -40 times 3 is 120. 120 divided by 5 is a -24. So my question in the chat room was, why did I only choose 2 numbers from the graph and not all 4? So why did I only choose 2? If I look back, these 2 are nice numbers to use. We can find those ourselves. We know what fractions that can be. We know that a half is 1/2 and a 0.6 is 3/5. However, if I look at these, I don't know which fraction is going to make that number. I could possibly try them all, and none of those are actually going to be my answer. Like, none of those are even going to work. Because I don't think any of my fractions there are going to give me 2.562. So since I only know these 2, I'm going to find these 2 by using them. As for these, the other 2, I'm going to use what I found here to do quadratic formula. So I am left with 10x squared minus 10x minus 40. instead of using the numbers 10, 10, and 40, can I pull something out of there? Can I take out the GCF? GCF is always going to make it that much easier for you. If I take out a 10, I'm left with x squared minus x minus 4. What's my A?
Mm.
1.
1. What's my B?
1.
Negative 1. And what's my C?
Negative 4.
Negative 4. Plug it into the quadratic formula. Negative B plus or minus the square root. B squared minus 4 times A times C all over 2A. Does 17 factor at all? No, it's a prime number. Therefore, I'm done. Those are my last two. My answers would be 1 plus radical 17 over 2, 1 minus radical 17 over 2, negative 1/2, and a positive 3 over 5.